Okay, hi. We're still waiting for others. Okay, hi again. 10, still waiting for more. Okay, 9 only. What happened? Can they connect? Okay, so we'll be talking about number 10, page 10. Now, like I mentioned before, your delta G naught is equal to negative N F E naught. Faraday's constant. Okay. What is a Faraday's constant? Faraday's constant is equal to 96,485 coulombs per charge carried by 1 mole of electrons. Okay? This is the amount of charge carried by 1 mole of electrons. So meaning if 1 mole of electrons move through the wire, it carries with it 96,485 coulombs of charge. Now, remember that E naught, what is the unit of E naught? Volt. Volt is the unit of E naught. Volt provided in the formula. But that allows fee, it's better to memorize because it saves you time. Okay? So E naught, joules per coulomb. It is the amount of energy or work that it could do for every coulomb of charge. And Faraday is the amount of charge given by a mole of electron. So imagine here, if this is mole, this is coulomb per mole, and this is joules per coulomb. We cancel the coulomb, we cancel the mole, we end joules. And that joules is actually your delta G naught. Are we clear about that? Is that clear? Okay. Now, what we're going to do today is we're going to see, this is not a battery. We're not doing a battery. It's just simple chemical reaction. Okay, can I erase? Because even without a battery, we should be able to, what do you call this? We should be able to determine whether a chemical reaction will proceed or not. For example, I'm looking at page 10 of my lecture notes. I hope you're looking at it. How about the volt? What is the volt? What's with the volt? Jar, what's with the volt? How about the volt? I didn't know what you mean. Oh, for example here, predict the spontaneity of the following reactions by calculating the delta G and E naught for the following. Look at this. Yeah, the volt is in joules per coulomb. The unit of E is joules per coulomb. Volt 2 sulfate solution. Now, the first thing you need to understand is I am going to look for the following: aluminum, iron. So I will go through the table. So if you go back to page 7 of my document, is there a problem with the connection? Okay, I am sorry. Yeah, it's okay. You can all go back because this is recorded. You can always go back and watch it at a later time if you want. Okay, so you have to look at this table. In this page. I hope you can see the table. Calculate. Yeah, we will have to calculate E first. But let's go. Let's do it like this. First, this is different. This is not the battery. We look for aluminum, and aluminum is like this. Aluminum 3 plus 3 electrons will give me aluminum. And then the iron 2 plus 2 electron will give me iron, and that will be negative 0.44 volts, and aluminum will be negative 1.66 volts. Now, here's the thing. For a battery, we know that this should be positive, meaning when you add them, they must be positive. But remember, this is not a battery. It's not necessarily a battery. We're asked, is this reaction spontaneous or not? That's a big difference, huh? Now, the first thing you need to understand, find your reactants. What are my reactants? Solid aluminum. Where is solid aluminum? That is your solid aluminum. Okay? Next, iron 2 plus. How did I know it's iron 2 plus? Because it's FeSO4. Fe2 plus. Nasser, focus. This is the iron you kept asking for. Okay. How do I know it's iron 2 plus and not iron 3 plus? Because look at this. This is Fe2 plus and sulfate. So we're looking at Fe2 plus. And where is iron Fe2 plus? It's here. If the ones that are put in green are the reactants, remember I need to flip one of them because both are reduction. Remember, one should be oxidation and one should be reduction. So I need to flip one of them. So which one would that be? The aluminum equation or the iron equation? We flip the first according to Badrani. Do you agree? Yes. Because here, aluminum is a product. We need it to be a reactant. Yeah, the aluminum. So we flip the aluminum half reaction such that aluminum will give me aluminum 3 plus 3 electron, and then iron 2 plus 2 electrons will give me iron. And then this will be positive 0.66 now and negative 0.44 volt. So we go this way, and then what's the next step? Yeah, we need the delta G to be negative. But how do we first? We need to find first the E. Hold on. The first step is to balance electrons. Guys, you need to balance electron first. It's 1.66. Yeah, you're correct. It's 1.66. Thank you. Multiply by 2. Yes, so we multiply this by 2. Not the E, just the electrons. And multiply this by 3. So that both of them will be 6 electrons. So this will be 2 aluminum plus 3 Fe2 plus will give me 2 aluminum 3 plus 3 Fe. The electrons are canceled. There's 6 electrons now. Yeah, n equal to 6. Very good. And then this one, you don't multiply with anything. You just add them. So this is going to be positive 1.22 volts. Spontaneous or not spontaneous? Do you think this will happen or not? Walash. What's that? Walash? Wash. You focus here on the class, mashallah. If the E is positive, obviously your delta G will be negative. So it will happen. So which means that delta G naught is equal to negative N F E naught. So it will be negative 6 times 96,485 times, what's my E naught? 1.22. And your number will be a negative number. So it will happen because it is in iron sulfate, a reaction will happen. That is what it means. That you will see a chemical reaction, meaning the aluminum will dissolve, will react with iron in the solution. Okay? Is that clear? I know it's lag, but you can watch this later. Remember? Okay. Remember that you can watch this later in the channel. I will make it available. It's your house. I have no jurisdiction over your house. I have only jurisdiction over the internet, but not over your house or wherever you are. Okay. So meaning, if I put solid iron in aluminum sulfate, nothing will happen. You see? You see why it is important? Because it predicts if something will happen or not. Okay? So if iron is placed in aluminum, so what I'm saying here is that, okay, let me just do this. So iron 2 plus, if you put aluminum, compared to iron in aluminum. Okay? See? So this one, we say that this will, the E naught for this one is positive. Obviously, the E naught for the opposite is negative. So this will be thermodynamically favored, and this will not happen. That is what it means. Aluminum, solid aluminum in iron, there will be a chemical reaction. Can you make tomorrow live at 9? Why? I only want period tomorrow. We start at, why 9? No, we can't. Oh, yeah, we can't. We need to be here 7:20 to 8:20 because it's a regular class. I'm really sorry. Okay? We cannot do live at 9. We need to be at 7:20 because it's a regular class. Please, mister, no, we can't because you have other classes, dear. You're supposed to be with other class. Okay. No question. Now, so for your homework, for your tasks, and then we'll stop here. For your tasks, you're just gonna. What about the full lab? It is canceled. Yes, no full lab. I mean, it doesn't make sense. We'll see. No full lab for now. We'll just do a demonstration for the lab, okay? Or hopefully when you come back next week, I don't know. We'll see. Guys, could you just do page 10 about the gold medal? We will try to do the virtual lab, okay? So your homework will be you don't need to submit it. You don't need to submit this one, but you try the gold metal in 1 molar HNO3. That is in page 10, huh? Check it out. And then we will discuss tomorrow. We will do cell potential in non-standard condition for tomorrow. That will be our lecture. Okay, yeah? Okay, so we're done. Are we good? Are there any questions? So for the rest of the time, you just work on the gold metal placed in 1 mole per joule. So do it now. Do it now. What will be the reaction for the homework? It's here. You don't need to submit, but you have to give the answer in the discussion board. Okay. Today. Meaning, okay, before you leave, so I will still be online because our class is still at 9 until 9:20. So if you still have question, write your answer in the discussion board and I will answer the question. I will end the stream. Okay? You look great today. Ugh. Okay. Okay. So we're good? So I only look great today, not the value of G. Yes. Where are we taking revision? Which revision? Which revision? Hot. What's hot? No, it's hot. It's cold. See? It's cold. He meant greater. What greater? Greater, mister. Always. I couldn't follow. Okay. Midterm. No, the revision will happen for March 29. Next week. We don't know. Next week. Okay. Okay, bye-bye.